Let's look at another example of writing our own power function y equals ax to the p. We're going to do it in 3 steps. Our first step, we're going to use the point with the x value 1 to find a. So I'm going to use that 0.13 and find a. My second step, I'm going to use the other point, the one without an x value of 1. So I'm going to use 472 to find the power p. And then I'm going to write the equation in the form y equals ax to the p. So my first step is to find a by plugging in my x and my y. So the y value is 3, and I have a, and my x value is 1 to the p. Anything to the first, or 1 to any power rather, is just 1. So we get 3 is a times 1. In other words, a is 3. Our second step, we're going to plug into y equals ax to the p again, but now we know our x and y value from the point, and we also know a from the first step. So the y value is 72. The value for a from the first step is 3. The x value of the point is 4, and we're solving for p. So I want to solve for p up in the exponent. I'm going to use logs, but before I do, I'm going to divide by 3 to get that 4 to the p on one side by itself. So I'll do 72 divided by 3, which is 24. And I'm going to leave some space. I have 4 to the p. I want to get that power out. I want to be able to bring it down. So I'm going to use logs to solve for any power. If this was log base 9, I would use log base 9 if it was 9 to the p. I would use log base 8 if I had 8 to the p. But since this is 4 to the p, I need to use log base 4. So I can grab my calculator and do log base 4 of 24. And my value for p, rounding to 2 decimal places, is 2.29. And my last step is to write my final equation. The equation is y equals a, which was 3, x to the p, which is 2.29. So I'm replacing a and p in there. And there's my final answer for the power function that goes from the 0.13 to the 0.472.